Hey, this is Mr. C. Thanks for tuning in to your latest math video. This is 3-1 Estimating Sums and Differences. You are now on to Chapter 3. Congratulations. Once you have your name and your date and this topic written, please unpause the video. We're moving on in 3, 2, 1. If you need to still check your homework for 2-7, please pause the video now. Moving on in 3, 2, 1. Alright, like we said, this is estimating sums and differences. We're asking the question, how can you estimate with decimals? And really the question that I'm interested in, because I don't really, in real life, when do you estimate? So a big question that I want to answer for myself in this video, and maybe you want to answer yourself as well, is when might you estimate? And so that's the whole reason why we're starting off with a word problem right here. Here's the definition of estimate, and if you're wondering, there is going to be a vocab slide right after this, so you don't need to write it right now, as there's nothing written in the top right. To estimate means to find an approximate answer or solution. I want you to pause the video and tell the person next to you what you think approximate means. Alright, so what you might have said was that approximate means about the answer, so about 12, if that was the answer. You just want to get close to the answer, not the exact answer. Alright, so let's read this problem. The 10-second barrier in the 100-meter dash was broken in the 1968 Olympics when the winning time was 9.95 seconds. Mrs. Johnson, the gym teacher, ran the 100 meters in 14.7 seconds. And it's very important, we didn't write it, but no one's making fun of her for that because that's still a very impressive time, Miss Johnson. About how much faster was the 1968 Olympic time than Mrs. Johnson's time? And there's a very important word in here that I want to clue, and it's about how much. They didn't ask how much faster was the 1968 Olympic time than Mrs. Johnson's time, because that would just be subtracting and you're finding the actual answer. But when they say about, that's telling me that they want an approximate. They want around the answer, but they don't want the exact answer. So there's two ways that we're going to do this, or that you could do it. So the first way, or one way you could do it, is to use rounding to quickly estimate sums and differences. Round each number to the same place value. So we're going to round each number to the nearest whole number. So where did we get these numbers? Well, we got them from the word problem. We got 14.7, that's Miss Johnson, 9.95, which is 1968, and this was some guy, apparently they don't want to give him glory, they don't say his name. By the way, Usain Bolt did beat this, just so we're on the same page. People have run it quicker than that. But they're rounding two whole numbers, so 14.7 goes to 15, 9.95 rounds to the nearest whole number of 10. Whole number means one spot right here. And then you subtract them, and that's 5. So this one, they rounded to the nearest whole number, and that's one way you can do it. Now I'm thinking, what is the next way? So another way to estimate, and this isn't wrong, it's just different. So another way is to use the front end digits to make a front end estimate. So let's look at this. See, they put in red 14 and 9. So the front end, I know that now that's just looking at the whole numbers. So they did 14 minus 9, and they got 5. But they make this statement here, which is going to cause me to look at this decimal. They said that 0.7 is less than 0.95. So then they came up with an answer that the difference is less than 5. So they looked at the first ones. The one spot, they subtracted them, they got 5. But then they looked at the decimals, and then they know the top one is less than the bottom one. So they're going to say the 1968 Olympic time is less than 5 seconds faster than Mrs. Johnson's time. So I see is about 5 seconds, and now they know this is less than 5 seconds. But let's just say, for example, this was at what we had, 14.97 minus 9.95. Well, you'd still have front-end estimate of 5, but see the top is bigger than the bottom, so you'd say the 1968 Olympic time is greater than 5 seconds because the top number is bigger as I compare those. Let's move on. Here are your vocab notes, and there's one more thing I would like you to write. I just wanted to remind you, and I know that we've all had this in past years, but if there's 5/10, you round up and you would make that one whole. And if it's 0.4, you round down to the 0 whole number. Pause the video right now, and we're moving on in 3, 2, 1. All right, so here's example 1. I know that you're going to copy this after I do it in front of you, and then you're going to try to do example 2 before the answer. In 1 and 2, complete each estimate rounding to the nearest tenth. tenth. All right, I'm looking at this. I know that the tenth is 7, and I also know the tenth is 6 right here. When I'm rounding to this or whatever they want me to round to, I'm going to look at the one behind it. I said previously that if it's 5 or greater, you round up. So 4 or less, you round down. And I'm looking at the number right behind the 7. I know that it's 6. That's greater than 5. I'm going to round up. I'm going to round 7 up. So I have 1.8 plus 0 point, and I'm going to look at the next one behind it, 8. That's greater than 5, 7. So now I'm going to add those together. And that is 2.5. We add those together. All right, next one, nearest tenth. All right, I'm finding the tenth. There it is. And to find out what the tenth is going to round to, I'm going to look at the one directly behind it. This is 5. That means we round up. So this is 20.5 minus 13.2. They got that because they looked at the 5. They know they round up. And we're going to subtract this. And I got 7.3 for my estimate. I know that 7.3 isn't the actual answer of this subtraction problem because we are estimating, but I know that it's about the right answer. It's close. Pause the video right now if you need to. Moving on in 3, 2, 1. Here's example 2. You are going to round each number to the nearest whole number to estimate the answer. Please unpause the video when you're ready. I'm going to show you the answers in 3, 2, 1. All right, so what I did was I knew I was rounding the whole number, so I looked at the next number behind it. That's 4, that's too small, it rounds down to 1. 5, that's a 4, it rounds down to 5. It stays at that 5. It does not round up. So 14, there's a 0, that obviously does not round up to 15, so we're going to stay at 0. Add 1 plus 5 plus 14, you get 20. By the way, I'm such a bigger fan of whole number rounding than tenths rounding. I mean, you can round, I understand that, we need to know that skill, but in real life I use this one more, so I am a fan of this. 72, I'm looking at the 2, and the 4 is behind it. I'm going to keep that at 72. That's too small, it doesn't round. And now I'm looking at the 9. I looked at the number behind it, 8. That's bigger than 5. We're going to round up. 59 plus 1, that's 60. 72 minus 60, that's 12. Pause the video right now if you need to, otherwise we're moving on in 3, 2, 1. So I wanted to talk specifically another real-life application. When would I use this? Please read this problem right here. So you're going to try right now to find a real-time scenario that you would use rounding. I want you to think, tell the person next to you when you actually would use rounding, and then unpause the video in 3, 2, 1. There's many things you could have said, but here are some possible answers you could have. Well, you want to find if you have enough money to buy 2 items you see at the store. You're going to round, so maybe there's G.I. Joe action figures, you know, one's at $7.78. You're really big into G.I. Joe action figures. Maybe you don't even know what they are, you know, whatever. But these are the prices. You're going to know you're going to need at least $8. And here you're going to need 7, so I should have at least 15. You know, I want to cover tax, so I'm estimating, I'm rounding up because I know tax can get you. I know I need at least $15. That's when you could round. Or maybe you could use the odometer on the car to find out how far you've traveled. The odometer, I know that the root meter means measure, and that just measures how far you go. You go on a trip, and on the odometer it says 13,131 before you go, and then after it says 15,030. I could round those to about 13,000 and then to 15,000. So I know that I traveled about 2,000 miles. That could be helpful. So I want you to look right here now and read this word problem, read it with me. And the reason why we're doing this is because we want to try the real life estimating. One northern Texas town received 13.29 inches of snow one year and 6.54 inches the next year. Please read the rest of this problem and do it before you work on. We're going to move on in 3, 2, 1. All right, as for this problem, I saw the words all together. I know that I'm adding, and I wrote the 2 amounts that it snowed. You could round to the tenths. That's one way you could have done it. You could have got 19.8 inches total, or you could have rounded them to whole numbers, which I'm a fan too, either 13 or 14 for this one. 13's obviously closer, so 13 plus 7, you could say that it snowed about 20 inches. There's a real-life scenario of when I might estimate. At this time, please go to page 62. Please do numbers 7 through 13. Here's special instructions for 11 through 13. When you're ready to check your answers, please unpause the video. We're moving in 3, 2, 1. Here are your answers. And I want you to pay special attention to down here. This is different today. Obviously, now you're going to go to your gas station on Socrative, but after that, I want you to choose. So look carefully at these options. You're going to choose the group math game from the activity folder, By the Door, and then Khan Academy, or you can go to Khan Academy right now. Your choice right now is really a choice of whether you'd like to work in partners in the group math game, By the Door, or whether you'd like to work by yourself. And you get to choose that after you do the gas station on Socrative. And if you do choose number 1, I'm going to show you the answers to the group math game in 3, 2, 1. Here are your answers. Thank you if you chose to do the partner game. Thank you for watching the video. And by the way, if you didn't remember, you are awesome.